So basically today we will talk about frame of reference, right? What is this? And like it's not included in a syllabus, but actually many questions are asked from this topic, which is frame of reference in this chapter material. It's quite important to study this, right? So today we will start frame of reference. What is this now? So let's talk about frame of reference. Now basically, what is frame of reference? When we observe, we can easily say that point from where we observe where we observe the motion in physics is known as frame of reference. So basically, it is a point from where we observe motion in where, like in physics, is known as frame of reference. Now, I know it's not clear to you from this definition. Let's make you more. Okay, you know that we have some orthogonal vectors, right? We have some orthogonal vectors. Okay, here I'm drawing this and this, right? So we know that this is I, and we know that this is I cap. This is J, and it's known as J cap, and it is K, and it's known as K cap, right? Now we know this I cap is basically the x-axis, right? This is x-axis, this is y-axis, and this is known as z-axis. Okay, the point from where we consider our motion, we observe motion, is known as frame of reference. So actually with these three, like with this I, J cap, with these three vectors and time is known as frame of reference. We can say when we consider I cap, J cap or K cap plus the time reference. When we refer to time too, that is known as frame of reference, right? So for example, let me draw another vector. Consider this is a vector. Okay, this is right, and I don't think so I have to write I cap J cap again. It's quite clear to you, and you guys are very familiar with this. Okay, for example, here this is a position, and this is point 1, this is point 2 in x-axis, this is 1, this is 2, and this is 3 basically, right? Now here we have, and now we have to tell the position, right? So its position will be like, first we'll put x-axis, which is in at x-axis we have 2, then it comma 3, because at y-axis it is 3. So we have written the position. So we have considered these points x and y. So it is known as frame of reference when we consider the motion with respect to a point. When we consider, when we, or you can say we observe the motion from a particular time, that is known as frame of reference, right? And with respect to time, as we know, this particle will be moving, right? Now it is in at 2 comma 3, like at x, in x it is 2 and in y axis it is 3. So it must that the time will be over here. Time will be, for example, time will be a 2 second here. But after some time, when the particle changes position, this time maybe will be like, obviously time will obviously increase 6 second, right? So with respect to time, these three vectors, these three orthogonal vectors from where we consider motion with time, along with time, is known as frame of reference, right? Now we have basically two frame of reference. Okay, why this frame of references were made? Now what, this is a big question, like what was the purpose, what was the need to make this frame of reference, right? So basically, okay, soon after this we will study Newton's law, right? So actually, according to some people, Newton's, like we know that Newton's law are valid all over the world, right? But according to some people's you can say assumptions, their theories, like there were many scientists, these like the Newton's first law, second law are not valid over there, right? So in order, for example, a place where the Newton's laws are valid is known as inertial frame of reference, and where it is not valid, it is known as non-inertial frame of reference, right? So now let's first discuss inertial. Oh my god, I'm stuck. Inertial. I'm unable to write. Okay, let's have a picture of this inertial frame of reference. So number one, we have inertial frame of reference, right? Inertial frame of reference. Okay, in this basically the body is either at rest, the body is in rest, or moving in uniform motion. Uniform motion, it means where the acceleration is not equal to zero. So which is basically where acceleration is equal to zero. So it means acceleration is equal to zero. It means there is no certain change in velocity. So it is uniform velocity, right? So body is in rest or moving in a uniform motion, that is known as inertial frame of reference. Okay, right? So here, this actually in this is valid in Newtonian mechanics, right? Newtonian mechanics, right? So let's consider over here a diagram. Basically, wherever the laws of Newton are valid, this inertial frame of reference is there, right? So we can say that the body is in equilibrium. The body is in equilibrium, right? Now next we have number two, which is non-inertial frame of reference, right? So what happens there? Basically, a place where the Newton's law are not valid, or you can say the body is accelerated. the body is accelerated at that time, the body is accelerated, or you can say the body is moving. The body is moving with non-uniform velocity, non-uniform acceleration, or with acceleration. There wasn't any type of acceleration. So here you can say we have elementary physics, or you can say Einstein's theory of relativity. It is all based on this, right? When we say E is equals to mc square. So basically, here where the Newton's law are not valid, that condition is known as non-inertial frame of reference. If we talk about Newton's, like if we talk about inertial frame of reference, we have the example which is Earth. So Earth is a very nice example of the inertial frame of reference. I like to tell you one thing, that all, like you say here, Newton's first law, or you can say all the laws are Newton's laws are valid, right? So I hope this frame of reference is clear to you, and now you'll be able to do any type of questions, MCQs which will be asked to you in any kind of test.